Okay, we're going to look at a silly, stupid game that's supposed to teach. So, here's a text file, not text, graphics. Anyway, it's got a sprite. This is a sprite. It's supposed to be a stadium looking from the pitcher's mound at home. And when we run this little game, you use the cursor and you peg the fans. And I don't know. I was bored. I don't know what I was thinking. Kind of a stupid, bad idea. Anyway, so this little gen will convert a text file to. This saves it as a graphics file, GRA. GRA is the proprietary graphics file format. It's like BMP, except it's got none of the crap. BMP is bad. This is a native GRA file is. Anyway, so what did it do? It did a DOS type, which will put graphics on the screen. Like if I say type and then stadium.txt.z. Well, anyway, obviously it puts that on the screen. Anyway, so let's look at the code. This is the main routine. It sigh. Anyway, so I try to keep consistent in all my demos. When you run from the command line, you want to save the settings because it's not a new task. If I say include we are the same task. So if I say who minus R, then this is the command line feeds into a C compiler, so I included that, and now we have all the labels as environment variables or whatever you want to call them. Anyway, so all the code is in memory, and anyway, so this saves the settings, and then we restore it when we're done, and that way the command line stays similar to what it was. Anyway, menu push. If you go up to the top when we run this, there's a menu, restart, abort. Anyway, so this is how you make a menu. It's pretty easy. Maximize the window, get rid of the border, get rid of autocomplete. Autocomplete, well, anyway, so then we run the init routine, then we spawn the animate task, and what is this background? Oh, that's I think that's a device context. We can blot a device context. If you look up here, we blot a device context. So here's the init. We have. Let's look at what global variables we have. This X and Y are the fans. The fans X and Y. The fans. Okay, so you can tell because I said there's 10 fans. Anyway. So get rid of the cursor. This turns the cursor off. This clears the text document that's up. Anyway, then we go into, this is the main loop, and we get a message if it's a key down. If it's a key and it's carriage return, we reinitialize. The restart from the menu will also generate carriage return. And let's see. So at the moment, if it's not a key down, this is a mask, which means we get two types of messages: key down or left button down. So if it's not a key down, then it's a left button down. And when you do a left button down, the X and Y are the two arguments. So the picture, well, I don't know why we bothered. Well, the picture's always in the same spot. Anyway, so the ball is launched when the ball time is not 0, then it's in the air. And so the animate is what handles the ball. So where do we set the ball time to 0? I don't know where we set the ball time to 0. That's strange. Oh, there's where we set the ball time to 0. Technically, that should be in the, we should put that in the animate, probably. So if the ball's in the air, then we draw the ball. And we rotate it. We rotate it by, oh well, anyway. So we rotate the ball as it's in the air. Let's see if that makes, you can't tell. But it, anyway, so the animate task, this does Brownie in motion. Watch the fans. Okay, that's Brownie in motion. That's what it's called. It's just random. So the sign function is either -1, 0, or +1. The sign converts, and if it's a positive integer, it's +1. If it's 0, it's 0. If it's a negative integer, it's -1. So anyway, just a simple demo. You would probably want to use a class, but for some of these simple demos, I used arrays just in case young programmers had never seen a class. Anyway, so that's what that does.